Now in this video, we'll try to understand some of the major drawbacks with the normal GRE implementations, the classic GRE we call them as. The first major drawback is they are point-to-point. Now, if you want to build a tunnel from router 1 to router 2, we need to build one tunnel from router 1 to router 2. And if you want one more from router 1 to router 3 and router 1 to router 4. So like that, if you just take an example, you have some 100 endpoints and you want to have a full mesh, every router should be connected to every other router, which means we are going to end up building up around 99 tunnels. And all the tunnel configurations has to be done manually on each and every point. So that's something make your GRE really not scalable for a big size networks. That's one of the major drawback with the GRE. Now, apart from that, the other disadvantage with the GRE is like there is no encryption here. Now, GRE does not support encryption by default, so which means whatever the information, it goes in a clear text and it's really not secure. Now, if you want to provide some encryption, what we can do is we can run GRE and we can run IPsec over GRE. So that's something a little bit advanced implementation. We'll talk about that more in detail about IPsec in the later on sessions. But as of now, by default, the GRE doesn't support encryption by default. So if you want to add encryption, probably you can go with IPsec implementations over GRE tunnels. Now, apart from that, there is one more thing, like we need to have a static IP address on each and every point. So especially if you're using internet connections, we are going to build a logical point-to-point connections from this point to this point, and these IP addresses has to be static. Now, if it changes, if these IP addresses are not via static, if they are using DHCP or if given by the provider and they keep on changing, in that case your tunnel interface will go down automatically, because the tunnel is established based on the reachability what we have between the source and destinations. And if you change the IP address or if it changes automatically based on some DHCP configurations, then it's really important, your tunnel will automatically go down. So tunnel has to be, the tunnel IP address, source and destination has to be a static IP addresses, and they should not be changed. If it is changed, we need to ensure that we also make changes to the tunnel configurations as well. Now, most of these drawbacks has been overcome in our next coming versions of the different implementations. Like we have a classic GRE as a point-to-point. Now, this drawback has been overcome in the next version. We have something called DMVPN implementations, dynamic multi-point VPNs, which is going to use something called multi-point GRE implementations. Now, the major advantage we get with this one is from one point we can have multiple destinations. So more similar to your frame relay point to multi-point implementations, we can connect one particular hub to multiple spokes. That's something possible, and we can use something called multi-point GRE implementations for that. So we'll get into that more in details in the DMVPN sections. That's something overcome in that. And apart from that, most of in the DMVPN, the tunnel configurations, we don't need to configure manual tunnels, so tunnel configurations can be automatic. Okay, and then for having encryption, again there is a solution. We need to use some IPsec implementations to overcome that. And probably in case of DMVPN, we can also have a dynamic IP addresses on the spokes. Now, these IP addresses can change. Even if they change, it will be automatically informed to the centralized router by using some NHRP protocols in case of DMVPNs. But if you talk about normal GRE, those things are not possible. Now, we must have a static IP addresses. It doesn't support encryption, not really scalable because all are point-to-point tunnels and it has to be manually configured. And these are the normal drawbacks of the GRE, which led to some of the new implementations of VPNs like multi-point GRE implementations or used in the DMVPN concepts.